Hello, dear students. So there, good afternoon and welcome to Maths 21st Super Channel together with the GCE Maths panel. In this particular lesson, we are looking at the factor theorem. Previously, we discussed the remainder theorem, and the factor theorem is an extension of the remainder theorem. To begin, the factor theorem states that if a polynomial f of x is divided by ax plus b and the remainder is 0, then ax plus b is a factor of f of x. So whenever we divide the polynomial f of x by ax plus b and the remainder is 0, then we say ax plus b is a factor of the polynomial f of x. The theorem is a special case of the remainder theorem when the remainder is 0. And this is much helpful in factorizing and in looking for unknown constants, or even solving a system of equations with two or more unknowns. Let us take an example. Find the remainder when f of x equals x squared minus 3x plus 2 is divided by x minus 1, and state whether or not x minus 1 is a factor of f of x. So the first thing to do here is to equate x minus 1 to 0. Then we solve for x. And when we do this, we are going to obtain x equals 1 as a result. We now look for f of 1 and see what we obtain. So f of 1 will be equal to, we have 1 squared minus 3 into 1 plus 2. And this gives us 0. This therefore tells us that x minus 1 is a factor of x squared minus 3x plus 2. And the reason is because the remainder is 0. So whenever the remainder is 0, it means the divisor, in this case, x minus 1, is a factor of the polynomial function. All right, let's take another example. Here we have given that x minus 1 is a factor of the polynomial function given as f of x equals 2x cubed plus px squared plus qx minus 2. And leaves a remainder of minus 6 when divided by x plus 1. A, find the values of the constants p and q. And B, factorize f of x completely. So we are being told in this question that x minus 1 is a factor. It therefore means when we divide this polynomial by x minus 1, we expect the remainder to be 0. So using the remainder or the factor theorem, we start by saying x minus 1 equals 0. We solve x and it gives us 1. So f of 1 is equal to 0 because we have been told x minus 1 is a factor. So substituting 1 into this equation will give us 2 into 1 to the power 3 plus p into 1 squared plus q into 1 minus 2. That should be equal to 0 from this equation. And when we simplify all this, we'll have 2 plus p plus q minus 2 equals 0, giving us an equation p plus q equals 0. Let's call this equation equation 1. The second condition here tells us that when you divide by x plus 1, the remainder is minus 6. So we are going to look for x plus 1 equates to 0. We solve x, that gives us minus 1. And from the concepts given in this question, we know that f of minus 1 should give us negative 6 because the remainder is negative 6 as we have been told. So we substitute x equals minus 1 into this polynomial. We'll have 2 into minus 1 cubed plus p into minus 1 squared plus q into minus 1 minus 2. That should be equal to minus 6. When we simplify, we'll have another equation. P minus q equals minus 2. Let's call this equation 2. Now from these two equations, if we add equation 1 to equation 2, we will have 2p's to be equal to minus 2, and p will be equal to 1. Substituting any of the equation gives us the value of q to be equal to 1. Therefore, the values of p and q are minus 1 and 1. Therefore, we can write this polynomial as 2x cubed plus p is minus 1, so minus x squared plus p, which is 1, plus q, which is 1, plus 1x minus 2. So this is the polynomial. We have this type of equations at advanced level. This is exactly what we do to solve this equation. The B part wants us to factorize f of x completely. We are going to use the idea of x minus 1 being a factor to factorize. Since you have been told, guys, that x minus 1 is a factor, we can proceed by using long division. So this polynomial function divided by x minus 1. So 2x cubed divided by x gives us 2x squared, and 2x squared times x gives us 2x cubed. 2x squared times minus 1 gives us minus 2x squared when we subtract. The subtraction sign is not written here, but you can write it, that's not a problem. So we have 2x cubed minus 2x cubed, that gives us 0. Minus x squared minus 2x squared, that gives us x squared. We bring down x. And now we can continue to divide because the degree of this is still greater than this, that of the divisor. So x squared divided by x gives us x, and now x times x gives us x squared. X times minus 1 gives us minus x. We subtract again, x squared minus x squared is 0. X minus x is 2x. We bring down minus 2. The degrees are now the same. Since the degrees are the same, we still divide. 2x divided by x gives us plus 2. Plus 2 times x, that is 2x. 2 times minus 1 is minus 2. Now, when we subtract, the remainder will be 0. Therefore, we can write the function of the polynomial f of x as x minus 1 into, that is the quotient, times the divisor. And we can factorize this quadratic completely because it is not yet completely factorized. When it's completely factorized, all the factors that appear here are in linear form, except one of the factors cannot be factorized. So this implies this is what we have. Now, when you look at the discriminant of this term, the discriminant of this term is negative. It means we cannot factorize this, or the answer, the factorized form will exist in the set of complex numbers. That's not our interest. So the last part was us to find the solution of the equation of x equals 0 in the set of real numbers. All the solutions of this particular equation are in the set of complex numbers, so we don't consider this solution. We consider just x minus 1 equals 0. So the only solution in the set of real numbers is x equals 1 in the set of real numbers. Here comes another example. Example 4 states when the polynomial p of x equals x squared minus 13x plus 3 is divided by x minus 3, the quotient is q of x, and the remainder is 0. Find the polynomial q of x, hence factorize f of x completely. So this is the polynomial. When we divide by x minus 3, the quotient is q of x. The first part of this question warrants us to look for q of x. So this can be represented as, this is a polynomial function. When we divide by x minus 3, we have another function q of x plus a remainder of 0. The remainder here is 0, so we can just omit this part. And from here, we can look for q of x in two ways. We can do long division to obtain q of x, or knowing that the degree of this one is 1 unit higher. The degree here is 2, the degree here is 1. So we know that qx should normally have the form ax plus b, such that when we multiply that degree, or if we add that degree to this degree, it should be equal to the degree of the numerator. Equally, q of x must have the form ax plus b, as we have just said. So if we have to proceed by expansion, we multiply both sides by x minus 3 and replace q of x by ax plus b, because we know this is going to be the form. So we just want to look at the values of a and b, and we will have our q of x. Or you can do long division of the left-hand side, you have q of x directly. That's another method. So we multiply this denominator by q of x, which is now replaced by ax plus b. We will have ax plus b into x minus 3. We expand the right-hand side and simplify. When we simplify, we bring like terms together. So we have ax squared, and these are the terms in x. So we have minus 3a minus b x. Note that this minus now appears here because if you say minus times this minus here, will now give us plus bx. And these are the constant terms. That's 3b plus 0. So we just write minus 3b here. Now you can equate coefficients. So to equate coefficients or compare coefficients, this is what we're going to have. For the x squared terms, we see that a is equal to 4. And then for the constant terms, we see that b is equal to minus 1. You can equally use this one, the terms in x. We will have the same results. Therefore, the value of q of x is, we already have a to be 4 and b to be minus 1. So Q of X should be equal to 4X minus 1. 4X minus 1. Don't forget to subscribe, guys. And if you don't have the previous videos in this particular channel, Math 24, you can get them from GCE Maths Panel. GCE Maths Panel. And equally, we have been told here to factorize this polynomial function P of X completely. To factorize this completely, P of X will be equal to, since the remainder is 0, we don't have to stress ourselves. Since the remainder is 0, we can obtain this function. We can factorize it directly by saying 4x squared minus 13x plus 3 is equal to x minus 3 times this Q of X times 4x minus 1. And that's why we have this. Equally, we have been told here that hence, it means we must continue with the solution or part of the solution of the previous sub-question. That's why we continue with this. Therefore, our P of X should be equal to this quotient times this divisor. That's why it's just one step, because the hence warrants us to continue with the previous solution. Equally, here we have another example on the factor theorem, and that to show that x minus 1 and x plus 2 are factors of the polynomial this. So we can actually multiply these two factors, and we'll have x squared plus x minus 2. We divide this polynomial by that x squared plus x minus 2, and the remainder will be 0. Or we can take one at a time. We can show that x minus 1 is a factor and x plus 2 is also a factor, and conclude that both are factors. So to show that x minus 1 is a factor, we just do the same thing like looking for the remainder. We just look for the remainder and show that the remainder is 0. So if the remainder is 0, therefore x minus 1 is a factor. And equally, for x plus 2, when we do the same thing, you see that x plus 2 is also a factor because the remainder is 0. The factor theorem can be used to factorize a polynomial completely using long division, provided one of the factors is known. If we don't know one of the factors, then we can proceed by testing the values. So we can test when x equals 1. We test until when we get the value equals 0. So for example, let me say they gave me this polynomial x cubed plus 3x squared minus x minus 3, and they asked me to look for the factors. I'll start by testing the value. Let x be equal to 1. Like here, when I fit x equals 1, the equation, I have 0 as a remainder. That tells me that x minus 1 is a factor. I can equally test x equals minus 1, test x equals plus 2, minus 2, but this value should be close to 0 so that we avoid complex operations. Thank you so much, guys, for watching. And here are some exercises. You know very well that when you watch these problems, it's very important that you look at the exercises, you answer all the questions that are available there to reinforce what knowledge or content you have gathered, so that you can equally improve your skills and your results. Don't forget to subscribe to this channel, and you can visit gcemathspanel.com online or www.gcemathspanel.blogspot.com. You can get past questions. For complete tutorials of this video online, just go to GCE Math Panel online classes or GCE Math Panel classes online. You are going to get all of this stuff there, lesson by lesson, for GCE and for GCSE. Thank you so much. Stay tuned and share these videos.